Hi guys, how we doing? Welcome back to another video. So I believe this is lesson 10 now, where I'm teaching myself how to program microcontrollers. So in this instance, I have a PIC 1618877, I believe, and I'm using the EBlocks platform, which is like a learning platform developed by the company that I now work for called Matrix. And so I'm going through their curriculum over here, which is 101 pages, and I'm now on the programming exercises, and I'm like on page 71. So there's not much left for me to do. I'm on page 72 actually. So in the last program, what did we do? We made a delay, and then we made, oh yeah, that was it. We made these LEDs turn on and off, and then we tracked them and looked at them on an oscilloscope. Hopefully, we don't need this oscilloscope in this lesson. So yeah, the plan today is using connection points, and hopefully we don't have to use an oscilloscope. So a connection point, or a go-to instruction. So being that I programmed in C, a go-to instruction is pretty simple. Is often used to create an infinite loop. Really? A connection point go-to instruction is used to create an infinite loop. To me, a go-to is like a break to jump over to a different function and go to a different part of the program. So, okay. Repeat a set of instructions over and over again. A better way to do this is to use a loop instruction. The advantages of connection point is that, so what's the connection point? Okay, yeah, it is a go-to. Okay. Is that it can be used to jump out of a loop to a certain location. Exactly, yeah. That's what a go-to instruction does. Yeah. The idea of a pulse modulation is introduced as a means of controlling LED brightness. Okay. So we've done all that background. So use connection points to introduce unconditional branching in a program. Yep, that's good. You introduce PWM as a means of controlling the brightness of LEDs, create an infinite loop, manipulate logic output levels, and use LEDs to display an output. So this looks like we're getting into more interesting code. So this looks good. So task number 1, write a program to see if you can use a delay, an output, and a connection point icons to light the even and odd LEDs of port B, alternatively on and off, with a 300 millisecond interval between in an infinite loop. Okay, that's a pretty big task there. All right, so I've got a delay from my last program, so I'll keep that, where I'm basically setting a variable to say delay is equal to 20 milliseconds. But this time we will set it to 300 milliseconds. Oh, just set it to 300. And then we want to turn on and off odd and even LEDs of port B. So we can get rid of port A there, duplicate port B, and then we have a delay. I guess the delay is going to go between the two of them. Yeah, yep. So we set the delay at the beginning of the program to 300 milliseconds. Set port B to just be all on, turn on the even, then to turn on the odd. Yep. So I haven't done that yet, obviously there, but I will. And do that in an infinite loop. So what's the connection point? I don't know what that is. That's the go-to, right? But so connection point, I'm looking for it here. Declare connection point, go-to connection point. I don't get it. Yeah, so I declare a connection point there, and then I go to it. I branch to it somewhere else, but obviously the first part of this, I don't need a connection point to do this, so I'll do it without the connection point for now because I don't see the point. So turn that, and then so we can get rid of all the rest of these. So to turn on the even numbers, what do I need? Let's think about this. I need number 1 is odd, even, odd, even, odd, even, odd, even. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 0, 1, 0, 1, 0, 1. So what's that? That is 2. Oh yeah, 6. Oh man, 12, and then 12 plus 16, 28. So that's 28. So I can just set that to 28. I'll do it in hex. What's 28 in hex? No, I'm not gonna do it. It's 1 a.m. I'm not about to start converting to hex. Oh wait, I just wrote that in hex. That's not that. 28. And then what's it to do this in the opposite? 1, 0, 1, 0, 1, 0, 1, 0. So we've got 1 plus 3 is 4 plus 5 is 9 No, 5. What? 1, and this is not 3. All right, 1, and then that's 2. Oh, bloody hell. Okay, just do this nice and keep it easy for my brain. 4, 8, 16. Oh, is no, my number there, that 28 is obviously wrong as well. I'm such a dumbo. Just don't mind me, guys. You know, obviously, the max is 255 here. I don't know how I would have thought that that would have been only 28. All right, 1, 2, 8. So this is 128 plus 32, which is 160, plus 8, which is 168, plus 2, which is 170. Let's turn on. Oh dear, man. Embarrass yourself on the internet. Why not? All right, 1 plus 4 is 5, plus 16. 16, yep, is 21, plus 64. 21, 85. Is that right? That seems, yeah, okay. We shall see, shan't we? So 85. So let's give that a download. Let's get rid of paint. So what that should do is it should turn, the room's a bit too bright again, isn't it? It should turn the LEDs even, then odd, then even, then odd in an infinite loop. Doing it? Okay, yeah. So it's turning it just even. It's not doing the odd because of I didn't add the delay. So I need another delay. This delay obviously needs to go there as well. And we can go again. Let me turn my lights off so you can see the LEDs. All right, there we go. Yeah, so we've got odd and even. So that works. I got there in the end. That's funny. Alright, so what does it want me to do with this connection point thing then? So test the program at first, step by step, and then continuously in the Flowcode simulator. Use delay, output, and connection point icons to flush the high nibble and low nibble LEDs. So what's the... I'm not a fan of... I don't understand. How do I just create a program using a delay, output, and connection point if I don't know what a connection point is or how it works? I'm not following here. So, all right, I declare a connection point. So I don't know. I don't know what this does. So I'm declaring a connection point. All right, let's call it Hamid's Fav program. A Hamid's Fav function. Okay. So I've declared a connection point, and then okay. So this is Hamid's favorite function, and we're gonna put that to the output of B, and then we're gonna say let's create another loop. I don't see the point in this, but okay. I'll create another loop, and we'll declare my delay of 300 milliseconds. Turn on port B's LEDs to even, and then go to that connection point that I've declared, which is Hammer's favorite function. So that should then jump out of the while loop and carry on, and then come back into it and do it all over again. But the most awkwardly long-winded program, and I actually have no idea if this is the intended use case of what this lesson is trying to teach me, but I mean that just seems completely, utterly pointless. So the code still works nice. So at least, I guess the intent here maybe is to simulate it, and then you can see. So how do I simulate run? There you go. So if I zoom out, slow it down, you can see it goes in there, goes to connection point, jumps out. Yeah. That, at least I've taught myself how to use that. I mean, use the delay output and connection point icon to flash the high nibble and low nibble LEDs of port B alternatively on and off with a 300 millisecond interval between in an infinite loop. I don't really want to do that, but okay. let's just see if I can do it quickly, hopefully. So I don't want to have to write in binary or to work stuff out in binary. So can I write in just binary? Like, will it? I guess it won't. No. What I'd like to do is, well, okay. I'm just going to write 255. I'm going to use masking. That's just going to be easier. So we'll turn off. I don't know if it said the high nibble or the low nibble. I'm not sure. Okay, it's flash the high nibble and then low nibble. So if you don't know what I'm doing here, in another video, it went through this. Basically, I'm turning on all of the LEDs by sending 255 as an 8-bit number, and then I'm using masking to then say, okay, but set all and that 255 with these this nibble being 1, so 1 1 1 1, meaning all on. So and if you and something with something that's on, then you get obviously that thing is on, if that thing's on. And then anding it with this nibble being 0 means that these are always going to be 0, because if you and something with 0, it's always 0. So therefore I'm turning all those on. So that should just be the exact same program now. I'm not sure, or not the exact same program, but that should, I can't see why that would work. So hopefully now I get those 4 on, those 4 back and forth. I mean, I'm moaning a bit, but I guess it's all practice, isn't it? Is it gonna work? No, it has not worked. Why not? Interesting. They're all on. I'm masking it. I'm so confident in my explanation. But yeah, the other alternative is just to work out what it is in binary, which let me just do now anyway. So is it 1 1 1 1, and then it's 1 1 1 1 0 0 0 0. Yeah, so that hasn't worked on the board. They were just turned on. So I don't want to write in. I don't want to have to be doing this. It's just a bit. I mean, I guess obviously in real life or at work, I just use a calculator. So what do I want to do? Binary to decimal, or the other way around. I want. Okay. Enter a binary number. So 0 0 0 1 1 1 1. That's 15. And then the other way, 1 1 1 1 0 0 0 0. 15 and 240. Cool. So since that's not working, let's turn off this masking, and then what is it? 240. So I haven't learned anything there, and that's what I'm not particularly enjoying about this situation here, because like, okay, that didn't work. I don't know why it didn't work. I don't know what the solution is. I'm not given the answers. I just, yeah, without giving me the answers, I don't know really what you want from me. So anyways, you can see it there. That code's now working. Nothing complicated about that, other than I don't know why it didn't work. But so that's done in an infinite loop. All right, so that's done. And then now use the delay and output icons to flash all the LEDs of port B on and off with a 500 millisecond interval in between in an infinite loop. I'm not going to do that. Again, there's only so many times you can do the same thing over and over again. There's no point in flashing them on and off. Download the program to microcontroller and test it. Yep, that's fine. Tip: make the delays in these programs very short and make the on and off times asymmetrical. This is a software PWM generator. When you run it, the intensity of the LEDs is lower. They flash on and off too fast for our eyes to observe. Instead, we need the intensity change. Okay. Write a program that lights LEDs on the 4 most significant bits of port B and keep them on. Wait, what? Lights the LEDs on the 4 most significant bits, okay, of port B and keeps them on. Okay. So that's that bit of code, 240. Dims the intensity of the LEDs on the 4 least significant bits of port B using PWM to create an observable difference in intensity. Well, wait, what? So they're telling me to use PWM, and I think this was their explanation here of how to make PWM. I mean, that's a, yeah, okay. So all right, so let's just do it. Okay, I kind of get what they're saying there. So you want me to write a program that sets this output for this port always on for these LEDs. But how does that, how do I then do the same? How do I write to the same port twice? I'm not with that there. It wants me to do that, but obviously that's going to overwrite that. I don't know what the... Make the delays in these programs very short and make the on and off times asymmetrical. Okay, so let's do that. So that would mean, let's just put my delay here as, what did it say, 8 milliseconds or 12 milliseconds, something like that. Let's do this one 12 milliseconds. And then make this one 8 milliseconds. I'm not enjoying this one, I don't think. 12 milliseconds, 8 milliseconds. Okay, so 8 on, 12 off. All right. I'm not sure what I'm trying to observe here, really. Is this supposed to look or be a PWM, I guess? Let's just download it and see what it is. So where I was flashing them both at the same intensity there, as you saw, I think now these are going to look dimmer. Yeah, I see no difference to me. Maybe. So you guys can't really see, but maybe what it looks like to me is these are brighter than those. Which, yeah, kind of makes sense to me, because what we did was we put, I thought it would be the 12 milliseconds on and 8 milliseconds off. So if it's the inverse, if I did 20 there and 5 there, I suspect now even you would be able to see a very clear difference between the two in terms of brightness. So I guess this is okay. This is creating PWM. I kind of get it now. I get what they're trying to do. I would have expected it to have been done differently, but okay. There we go. So, I mean, obviously, what's interesting is my eyes cannot pick up the flashing. You guys can. So when I'm looking at now my screen recorder, my camera, I can see it flashing, like it's flickering like mad. So the camera is capturing that, but my eye, I'm not seeing it. Like, and obviously you can see it, but I can't. To me, those look bright, those look dim. Yeah, I mean, even if I stare intently, I can't see the flashing. So that's pretty cool. That. So this is our fake PWM. I mean, yeah, well, I guess yeah, it's a real PWM. That's cool. I can't see how I'd use that, but or maybe that is just how you do PWM. I don't know. I'm not fully. I haven't fully grasped this yet, but I kind of get it. I don't know. All right. So write a program that lights LEDs on the four most significant bits, which is those, and keeps them on. Dims the intensity on LEDs on the least significant bit to create an observable difference in intensity. Yep. Use an oscilloscope to examine the signal controlling one of the four least significant bit LEDs. Tip: the MSB is the left. It's a bit late. A bit late for that tip. All right, cool. Let's get the oscilloscope going then. All right, so I should really get some better probes. I'm currently using alligator clips with little breadboard wire. So if I go across this LED, all right, now how do I scale this? Okay, so oh yeah, I just turned on my, so my time set to 20 microseconds there. So 5 volts, and let's set it to let's do 20 milliseconds. So time interval 20 milliseconds, we should see. There we go. So we have a tiny Juke cycle there. So that's apparently a 20% on cycle, 8% off cycle. That's on those LEDs. They're dim ones. Again, they're flashing like mad on the camera, but they're not in my eyes. And then on the bright ones, yeah, we've got an 80% on cycle, 20% off cycle. That's cool. I like that. Yeah, that's nice. Cool. All right, that was a somewhat interesting lesson. I mean, I didn't fully. I'm not. I'm just. I guess I'm. I expect better lessons, to be honest with you. And I think I'm able to make it work. Because I'm an employee of the company, so I'm invested in it working. And the guys I know that have built this stuff, the ones that made the curriculum, the ones that built all these boards, they still work there, and they're brilliant. Way smarter than me. So I know the people, and I'm like, they're not dumb. They know what they're doing. So I'd expect this to work. But I think if I didn't know the company and I was just using a kit, I'd just be like, this is shit. Like, this is not intuitive. I wouldn't put this much effort into trying to make it work. I'd just be like, you haven't explained it. Why am I using this sort of thing? So, yeah, I think one of the things I need to do in future is just work on improving this. Maybe, I don't know, maybe, my boss and others will tell me that this is actually how they want to. They want to challenge the student. But to me, this is just, it's too much thinking. There's at least tell me where to put my oscilloscope. So yeah. Anyways, I enjoyed that. Like I said, it was fun, actually. So it's kind of, this is a weird experience for me where I'm enjoying it, but I'm not enjoying it. So anyways, all right, next lesson or next tutorial will be these on tutorials. Next learn with me will be performing calculations. So I'm not going to read that because I end up reading it again twice. So yeah, we shall continue in the next video. Thanks for watching, guys. Take care. Bye bye.